Hi, in this video we are going to be having a discussion on the graphs of logs function, logarithmic functions. Now we know that the graph of the e to the power of x and ln x are basically inverse of each other. These are inverse functions, so the graph of these functions are going to be reflection of each other in the line y equals to x. So we know that the graph of e to the power of x was like this. So ln x graph is going to be a reflection of the graph in the line y equals to x. So we get this as a reflection. Now, for example, if the function is y equals to ln x and we want to find the x-intercept, we are going to plug y as 0. So solving this for the value of x would be equal to e to the power of 0, which is 1. Hence the x-intercept is 1. Now ln x is only defined for positive values of x, because for a log to be defined, this value of x, log of a positive number, is only defined. So this value has to be positive. So that's why we are going to have a graph towards for the positive x values over here. Now as x approaches 0, as the value of x approaches 0, we can see that the graph goes towards negative infinity. And as x value becomes very large, infinitely large on the right hand side, the value of the function also becomes infinitely large, that is the y value reaching to positive infinity. Now we are going to be looking at the variations of the log graphs. The first is the graph of the form k times ln x. Consider the simple graph of ln x. We know that the x-axis is going to be serving as the asymptote, which means that the graph of ln x is going to be getting closer and closer uh, to x equals to 0, but it's not going to be 0. So the x-axis line serve as the asymptote, and the x-intercept is going to be 1 comma 0. Now if you want to sketch the graph of 5 times ln x, so the general shape is going to be the same. It's just that now the steepness is going to change. 5 times ln x would mean that every y value is going to be multiplied by 5. Every y value is going to be multiplied by 5 other than this value, which is 0. So it is going to remain as it is, because 0 times 5, over here at this point the value of ln x is 0, so 5 times 0 is still 5. And for this part of the graph is going to become further negative. After multiplying by 5, the part below the x-axis will become further negative, because it is going to be multiplied by 5. So the graph of 5 ln x would also be of this shape, but it's just going to be steeper than ln x. Now the graph of minus 5 ln x, when you multiply a function by a negative number, it basically reflects the function in the x-axis. So if this is our function 5 ln x, sketching the graph of minus 5 ln x would mean that the graph of 5 ln x has been reflected in the x-axis. So the value at positive 5 would become minus 5. So the general shape comes out to be like this. It's going to be a decreasing function. As the value of x increases, the value of y decreases. And for minus 5 ln x, as x approaches towards 0, the y value approaches towards a positive infinite value, and as x approaches a very large value, the y value approaches negatively large value, negative infinity, towards negative infinity. Now let's consider the graph of ln ax. Now this a is just responsible for horizontal stretching of the graph. So let's consider the example of y equals to ln 5x. Okay, so to find the x-intercept, we are going to plug in y as 0, and e to the power of 0 is going to be equal to 5x, which means 5x equals to 1. So which means x equals to 1 upon 5, or 0.2. Now the x-intercept from 1 reduces down to 0.2. So the general shape is going to remain the same like this, and the x-axis is going to be our asymptote line. The asymptote line is a line where the graph of ln x is going to approach, but it's not going to intersect. Let's consider the graph of y equals to ln half x. Now the general shape is still going to be the same. We just need to figure out where it is going to cross the x-axis. So for that we are going to substitute y as 0. E to the power of 0 is 1. So e to the power of 0 is going to be half x. 1 equals to half x. So x is equals to 2. That means that this graph is going to intersect at 2. So that's our graph for ln half x. You can notice the difference between ln x. This is our graph for ln x. This was the graph of ln 5x, and this is our graph for ln half x. So as the a value reduces down, the x-intercepts gets further and further away. Now the equation over here is ln of minus x. Now I just mentioned that log of a negative number is not defined. So for us to have a graph of ln of minus x, then x value must also be negative. That is why the graph only exists towards the left hand side. This x value is going to be negative, and the negative value multiplied by negative over here will generate a positive value. So then the log of a positive number is going to be there. So the only difference over here is going to be that it's going to intersect at minus 1, because if the equation is y equals to ln of minus x, and to find the x-intercept, e to the power of 0 is equals to minus x. So 1 equals to minus x, therefore x equals to minus 1. The graph is going to be the other way around. It's going to be the reflection in the line. It's going to be reflection in the line of y-axis. Consider the graph of ln x and consider the graph of ln minus x. They are reflection of each other in the line y-axis. Let's now discuss the graph of the form ln x plus b. Now this plus b is responsible for horizontal translation. Okay, so for example, we have y equals to ln x graph. Now for ln x graph, we know that the y-axis having the equation of x equals to 0, acts as a line of asymptote, and this is our basically the graph of ln x. Now if the equation is y equals to ln x plus 2, how will the sketch be different? Well, for the log to be defined, we know that this number x plus 2 must be greater than 0. So if we want this x plus 2 to be greater than 0, then x value must be greater than negative 2. Hence the asymptote line is now going to be at minus 2, and the graph is going to start after minus 2. So the next graph ln x plus 2 starts from here, and to find the x-intercept, we are going to substitute y0. So e to the power of 0 is x plus 2, x is equals to minus 1. So we can calculate that the x-intercepts comes out to be negative 1. And now for the equation y equals to ln x minus 4, y equals to ln x minus 4, this function is going to be defined for the values where x minus 4 is greater than 0, which means x values must be greater than 4. So the vertical asymptote is going to be x equals to 4. The graph is going to be drawn after 4. So you can observe that the graph starts after 4. To find the x-intercept, we are going to substitute y as 0. So e to the power of 0 is equal to x minus 4, x equals to 5. So it means that the x-intercept is going to be 5. And finally, let's consider the graph of the form ln ax plus b. Again the same thing. So consider the equation ln 2x plus 6. So ln 2x plus 6, if that's the equation, then this 2x plus 6 must be greater than 0, so x must be greater than negative 3. So that's why the asymptote has an equation x equals to minus 3. And then we are going to draw the graph, we are going to draw the sketch. We observe that it's going to have an x-intercept and the y-intercept. So to find the x-intercept, we are going to plug in y as 0. So e to the power of 0 is equal to 2x plus 6, 2x equals to minus 5, x equals to minus 2.5. Therefore, the x-intercept is minus 2.5. To find the y-intercept, we can just plug in x0, so y comes out to be ln 6. So this point is going to be ln 6. Let's do one more example. Uh, let's consider the graph of ln 2x minus 6. Now to sketch the graph of ln 2x minus 6, first we need to figure out where the asymptote line is going to be. So log is defined for a positive value, therefore 2x minus 6 must be greater than 0, so x must be greater than 3. So the vertical line is going to be at 3, which means that you are going to start sketching the graph after 3. Now you can sketch the graph, and then to figure out this point, the x-intercept, you are going to substitute y as 0 in the equation. So e to the power of 0 is equals to 2x minus 6, 1 equals to 2x minus 6, x equals to 7 upon 2, that is 3.5. So the x-intercept comes out to be 3.5, and this function will not have any y-intercept. Okay, let's do a past paper example. We have to sketch the graph of the curve y equals to ln 4x minus 3 on the axis, stating the intercept with the x-axis. It's a 2-mark question. So the equation is y equals to ln 4x minus 3. In order to sketch the graph, first I need to find the equation of the asymptote. So this value 4x minus 3 must be greater than 0, and x must be greater than 3 upon 4. 3 upon 4 means 0.75. So we are going to draw a vertical line at 3 upon 4, somewhere around here, 0.75 or 3 upon 4, and then the basic graph is going to be like this. And then we need to find the x-intercept. So to find the x-intercept, we are going to plug in y0. So e to the power of 0 is equals to 4x minus 3, 1 equals to 4x minus 3, 4x equals to 4, and x comes out to be 1. So this point is 1. So that is the graph for y equals to ln 4x minus 3. Thank you for watching this video.